Could 8 billion people actually shake the Earth simply by jumping at exactly the same moment? It sounds like one of those questions everyone has heard at least once. Maybe you've even wondered about it yourself. If every person on the planet counted down together, jumped into the air, and landed in perfect synchronization, would the ground beneath us react? Or would Earth continue as if nothing had happened? The idea feels convincing because the number itself is overwhelming. 8 billion people is almost impossible to imagine. Every city filled, every stadium packed, every village, island, and remote settlement participating in the same countdown. Humanity has never acted with such unity before. If we all performed the exact same action, surely the planet would notice, wouldn't it? Before answering that question, we need to ask another one. What actually makes the Earth shake? Most people immediately think about weight. After all, billions of people together weigh an astonishing amount. But earthquakes aren't caused simply because something is heavy. Mountains weigh far more than humanity. Yet they stand quietly for millions of years without making the planet tremble. The secret isn't weight, it's change. The ground only responds when forces suddenly increase or decrease. That's exactly what happens every time you jump. Your legs push downward, the Earth pushes back, and for a brief instant, you leave the ground. The real impact comes a moment later. When gravity brings you back down, every landing transfers energy into the surface beneath your feet. Usually that energy disappears almost instantly. One person creates a vibration far too small to notice. 2 people create 2 tiny vibrations. 1,000 people jumping together begin creating something measurable. The question is no longer whether one jump matters. It's whether billions of tiny impacts can become one enormous event. We already know humans can shake the ground. During major sporting events, excited crowds jumping in unison have produced vibrations strong enough to appear on nearby seismometers. Rock concerts have done the same. Even synchronized military exercises sometimes generate detectable seismic signals. Humans really can make the Earth vibrate. So let's multiply that idea beyond anything history has ever seen. Instead of 50,000 fans inside one stadium, imagine every stadium on Earth, every school playground, every sidewalk, every rooftop, every open field. Billions of people preparing to jump during the exact same second. For one brief moment, something remarkable happens. Every human being is airborne. The force we've been applying to the ground suddenly disappears. Then, less than a second later, everyone lands. Across the globe, billions of tiny impacts strike the surface almost simultaneously. Sensitive scientific instruments would detect it immediately. Seismic stations scattered around the world constantly monitor vibrations moving through Earth's crust. They can record earthquakes happening thousands of kilometers away. They can detect distant explosions. They can even distinguish different types of seismic waves. Humanity's synchronized landing would almost certainly become visible across the global monitoring network. But detecting a signal isn't the same as creating a disaster. The Earth would shake, just not in the dramatic way our imagination suggests. Most people picture one gigantic impact hitting the planet. That's impossible because humanity isn't gathered in one place. We are spread across almost every continent. Some people live in crowded cities. Others stand on isolated islands. Some live deep inside forests. Others high in mountain villages. Oceans separate entire populations by thousands of kilometers. Instead of one enormous impact, Earth receives billions of tiny taps scattered across its surface. Those vibrations immediately begin traveling through the ground. Some move through solid granite. Others pass beneath deserts, forests, or ocean floors. Every type of rock changes their speed. Every underground layer bends their path slightly. The deeper they travel, the more complicated the journey becomes. At the same time, the waves begin losing energy. Rock isn't perfectly rigid. It absorbs part of every vibration. Tiny imperfections inside Earth's crust convert mechanical energy into heat. Mountains scatter the waves. Faults redirect them. Long before vibrations from distant regions meet, much of their original strength has already disappeared. Imagine throwing a pebble into a quiet lake. Ripples spread in perfect circles before slowly fading away. Now, imagine throwing millions of pebbles into lakes all over the world at exactly the same time. Every lake becomes disturbed. But none of those ripples somehow combine into one giant global wave. Earth's crust behaves in much the same way. That doesn't make the experiment uninteresting, quite the opposite. Scientists would probably celebrate the opportunity. Never before has humanity produced such a perfectly timed global event. The resulting data could reveal subtle details about how seismic waves travel through different parts of Earth's interior. Yet nature performs far greater experiments every single day, without asking anyone's permission. Ocean waves constantly pound coastlines with incredible force. Powerful storms shake entire mountain ranges. Massive landslides send millions of tons of rock crashing downhill. Compared with these events, humanity's greatest synchronized jump begins looking surprisingly modest. Then there's the moon. Every day its gravity quietly lifts entire oceans. Billions of tons of seawater move across our planet in an endless rhythm that has continued for billions of years. Those tides involve vastly more energy than every human on Earth could generate with one perfectly synchronized jump. Even earthquakes provide another sense of scale. A moderate earthquake releases more energy than humanity could ever hope to produce through jumping. The largest earthquakes reshape coastlines, move sections of Earth's crust by several meters, and release energy equivalent to countless nuclear explosions. Our synchronized landing wouldn't come remotely close. But another fascinating question now appears. If billions of people all push downward at once, shouldn't Earth be pushed upward? Newton's third law says every action has an equal and opposite reaction. Surprisingly, it does. For an unimaginably tiny fraction of a second, Earth really would recoil. The entire planet would shift in the opposite direction of humanity's jump. The movement would be real. Physics demands it. But reality also demands perspective. Earth's mass is approximately 6 sextillion kilograms. Compared with that unimaginable number, humanity is almost weightless. The recoil would measure far less than the width of an atom. Before anyone could ever hope to observe the motion directly, gravity would already be pulling every jumper back toward the surface, canceling almost the entire effect. Earth's orbit around the sun wouldn't change. Its rotation wouldn't slow down. The length of the day would remain exactly the same. Satellites would continue orbiting normally. The moon wouldn't drift away. Nothing in the solar system would suddenly behave differently because humanity decided to jump together. Ironically, the greatest challenge wouldn't be physics at all. It would be organization. Coordinating 8 billion people across every time zone, every language, every culture, and every political border would likely become the largest cooperative effort in human history. The countdown itself might be a greater achievement than the jump. And perhaps that's the true beauty of this question. It begins with a simple childhood curiosity, but quietly transforms into a lesson about scale. Not the scale of humanity, but the scale of the planet beneath our feet. We often think of ourselves as powerful because we've changed landscapes, built cities, and explored space. Yet, compared with Earth itself, our combined strength remains astonishingly small. So, could 8 billion people shake the Earth? Yes. Instruments around the world would almost certainly record the event. But could humanity move the planet, trigger a catastrophic earthquake, or alter Earth's journey through space? Not even close. Sometimes the most fascinating thought experiments don't reveal what we're capable of changing. They reveal the unimaginable size of the world we've been standing on all along.